Assalamualaikum warahmatullahi wabarakatuh. I will be doing the introduction of this project. So our project focuses on building a Bluetooth control car using the AXP microcontroller EXP8266. As we all know, the technology is rapidly changing. How we interact with the world around us using wireless communication like Bluetooth has become enabling seamless control communication in automation in countless applications. And due to simplicity, reliability, and also it is also widespread availability, make it an ideal choice for short range communication. Integrating Bluetooth into microcontrollers like EXP8266 has unlocked a world possibility for creating innovative and cost effective devices. This project specifically leases on ESP8266 to develop a Bluetooth control car. It is also a powerful microcontroller known for its robust processing capabilities and its built-in Bluetooth functionality. So this versatile platform developing an interactive and mobile robotics project. It is about building a remote control car. It is about providing a practical one like wireless communication. And Bluetooth control car, this designed for user friendly, operated via smartphone or any Bluetooth enabling devices. The intuitive control method, it makes it accessible and engaging for users. It can be valuable tool for teaching robotics programming and electronics. In prototyping, it can be also used quickly test and iterated on mobile robot designs. By integrating hardware and software components, this project provides a valuable insight into the design that implementing of a real-world robotics system. Alright, the next is problem statement. Factorize often encounters significant challenges such as inefficiencies in material handling, equipment monitoring, and navigating confined or hazardous space. So traditional systems which rely on wired connections or expensive automated solutions can be costly and inflexible, and it's also difficult to adapt to dynamic needs of industrial operation, ultimately hindering productivity and increased operational complexity. To address these challenges, our project introduced a cost-effective and versatile wireless control system designed to enhance mobility and improve efficiency and offer flexibility for various industrial applications, including transporting materials, inspecting equipment, and navigating restricted areas. By leveraging wireless technology, we eliminate the constraints of traditional wired system, reducing installation and maintenance costs while enhancing overall operational efficiency. This adaptability can be tailored to meet the specific needs of different industrial environments, ensuring business can respond swiftly to changing demands. And in summary, our wireless control system represents a significant step forward in transforming industrial operation, paving the way of more productive flexibility future.
Hi everyone, my name is Davanisha Suresh. My matrix number is CN220323. Here I'm going to present about objective of our project. Our study focus on evaluating the market landscape, consumer trends and competition pertinent to the new product. The first objective of our project is design of automate cart. To design an automate cart capable of following a predefined path using interference sensor, ensuring efficient and precise navigation. And our second objective is development of sensor-based navigation. To develop an accurate and consistent navigation system by implementing robust sensor-based control mechanisms. The third one is evolution of performance and reliability. To evaluate the performance and reliability of the line following mechanism is structured environments, ensuring this applicability and effectiveness. Here we go. Next is problem statement of our project. First is to utilize Arduino Uno and infrared sensor to implement the line following functionality. Second is limited accessibility, manual operation or reliance on advanced robotic reduce the flexibility of automation in smaller or resources constraints returns. The third one is high cost and complexity. Automation systems are expensive and difficult to program, limiting their accessibility for smaller organization and institution. Thank you.
For our scope, we have three core functionality, efficiency, and scalability. So for core functionality is maintaining a steady and dependable connection between a node and MCU and the IoT platform. So the efficiency is balancing the power requirements of the microcontroller, motors, and other components while maintaining the optimal performance. And lastly, this capability is demonstrate and scalability for potential adapted to more complex environment and task. For chapter 2, literature review, I will be presenting first on introduction. This chapter truly of review research and projects centered around Bluetooth control system, wireless communication technologies, and also robotics. We examine the gaps in current methodologies and the limitations of previous solutions, and the advancements that shape the foundation of this project. Focus lies on the key studies that technologies in industrial automation, particularly Bluetooth-enabled devices, motor control system, and also robotic navigation in constrained environment. By understanding these advancements, we set the stage for developing innovation solutions to address these challenges. On this next slide, this is a literature review reference. I already picked out three of the reference here, and the literature review that shed light on the advancements and device application of automatic system and motoring technologies. So let's dive in for the first work Dominator ME et al. In 2021. This study integrates QR code, RFID, and biometrics methods, showcasing that the potential of IoT, which is Internet of Things, is in campus-wide monitoring system, and by employing technology such as NFC, Wi-Fi, and Bluetooth, this system allows the seamless location tracking across the campus. Incorporation of multiple tracking modulators ensures the robustness and accuracy, paving the way of smart campus solution and enhance the security and operational efficiency. For the next reference, we turn to the contribution of Sando VK and Vanapalli NRN 2023, who developed a line following robot with integrated obstacle detection and avoidance capabilities. This robot employs the infrared sensor for path tracking and ultra sensors for real-life obstacle detection, as a sophisticated control system allows that robot to adjust its navigation dynamically, enabling safe and efficient operation in unpredictable environments. This also works highlights the importance of combining path following accuracy and environmental awareness, essential for applications such as warehouse and automated or rescue missions. Last but not least, the last reference that we picked is the consider of the work of engineer C in 2022, which represent a line following robotic utilized on ESP8266 called microcontroller that we use in our project, and a QTR8RC sensor array as a reference, and also a PID control algorithm. This system is designed for high precision navigation, and with PID controller adjusting motor speeds based on sensor feedback. And the use of the affordable components like ESP8266 makes it the innovation not only effective but also accessible to enthusiasts and researchers aiming to explore the robotic automation, and it's also affordable.
Assalamualaikum and Salam. So this is methodology chapter 3 for our project. In this chapter, as we can see, we have a flow chart on how we conducting our methodology. Component selection using ESP8266, motor driver module L298N, motor driver, TTDC motor, car chassis, jumper wires, and so on. For the circuit design, it will be explained on the next slide. The software implementation, we are using FreeZing for our circuit design, and that we can download it from Google, directly from Google. And then we also using Arduino, IDE Arduino to insert our coding in this project. Testing, troubleshooting, and organization is conducted at the same time in this project. So this slide is a circuit and hardware design. As you can see, the middle one, the right one is a motor driver. It will connect directly to the motor DC, four motor DC that are mounted there. And also there's 3 pin. You can see the power supply will direct go to 12 volt, and then the ground will also connect to the ESP. And if you look it a little bit further, there's 4 pins. I'm using a D5 till D7 till D8 and connected to input 1, 2, 3, and 4. So and for the hardware design, at the left side, at the right side, you can see that is the final outcome in this project.
For this slide, we're going to talk about the software that we use for these projects, and number one is actually Tinkercad. And the purpose of Tinkercad is used for 3D design that we already put in the slide. You can refer. And it is for 3D design electronic simulations. It helps design the robot, castings, and other 3D components, ensuring it fit together efficiently. And the electronic simulation feature in use creates the test virtual circuits for ESP8266 which is a Wi-Fi module, motors and sensors before physically assembling them. Next is Fizzing. It is an open source software that creates a documenting electronic circuits that use for design the circuit diagram for the robot car, and including the connection between ESP8266 microcontroller, motor driver, and also TT gear motors. Help it visualize how components will be replaced on a breadboard or PCB, aiding in proper assembling and reduce wiring errors. Last but not least, Arduino, which is we use for hardware platform and the software IDE for programming microcontrollers, and it is also used to write and upload the code for the ESP8266 microcontroller libraries. The scripts enable the motor, control Wi-Fi communication, and handling the real-time commands, provide a platform to test then debug the software to ensure the seamless operation of the robot. And lastly, there is the ASP8266 Wi-Fi robot car that is actually not a software. It is actually an app, which is actually a freeware app. It is free in any devices, iPhones or even iPhone and Androids. And its purpose is to act as a controller for the robot, and the central processing unit for the robot also receive Wi-Fi commands from the smartphones or other devices, processing these commands and control the motor driver to move the robot forward, backwards, or even a specific direction, which you can actually control, maintain the connection, and enables real-time control, ensuring the low latency in response to its user input.
So this is a result and analysis for our project. As we can see, we have forward, reverse, left and right. This one is from our application ESP car module controller, and then the output we have motor 1, 2 and 3, motor 1, 2, 3 and 4. So when I press forward, okay, the motor 1, 2, 3 and 4 will energize and make the car move to forward. And then for the second one is when I press reverse, the motor, all the four motors will go reverse at the same time. But if I didn't press any forward button or reverse button, I only press right button. Therefore, motor will not energize. Motor will only turn to left, turn to right only. It will not move to the right. It will not energize to the right. And the same also goes with the left button. When if I only press the left button, the motor will the card will stay at its original place. But if I press forward button and the left button, motor motor 1 and motor 3 will energize and make a turn. Meanwhile, the motor 2 and 4 will de-energize to make sure that the card will only moving to the left. Same goes with forward and right button. If I press those two, the motor will turn to the left, but the motor 1, motor 3 will de-energize and motor 2 and motor 4 will energize. Same goes with the reverse. If I press the reverse button to the left, it will reverse to the left. If I press reverse to the right, and then the motor will reverse and turn around. In conclusion, the Wi-Fi controlled robotic cart project successfully demonstrated the integration of ESP8266 for seamless wireless communication and precise motor control using motor driver. The project achieved its goal of remote operation via a web interface, showcased the potential of IoT in robotics while the cart performed well in terms of connectivity and functionality. Future enhancements, such as editing a camera, obstacle detection sensor, gesture-based control certificate its capabilities. This project provides a value insight into hardware-software integration, IoT application, and practical problem-solving in robotics.